Okay, correct negation of every father has a daughter. Which one do you think it is?
Every father does not have a daughter.
Every father does not have. Yep. Need a mark.
We're talking about negations as one in my household.
Were ya?
Because my mom did the laundry bin, but is actually just standing up straight. And she said, it's the exact opposite. How did you miss it? I said, it's not what it usually looks like. And I said, wouldn't the opposite be like this? And she said, no.
All right. If A is 3, 6, 7, 8, B is 5, 7, 9, 10, what's A or B? Union, that means you can't write that as an and, right? Remember I told you always take it and see if you can write it as the word and. If you can't, it's the word or, correct? And or often means more. In either or, you're going to list it.
Oh, that shot really hard.
We're all just going to stay real still. There we go. All right. So we have 3, 5, 6, 7, 8, 9, and 10, which is C. P is 2, 4, 8, and 16. Factors of 6. Factors means what multiplies to be 6. So it's going to be 1, 2, 3, and 6. And then R is 4, 8, 12, and 16. Which sets are disjoint? Disjoint means what? What does disjoint mean? They don't share anything in common, right? So which ones don't share anything in common? Q and R, correct? Because if you go Q, intersection R, you would get what? The empty set. If you get the empty set, it's disjoint. So when you do the intersection of two sets and you get the empty set, that means they're disjoint, right? Okay. Intersection is this symbol. And what's that? Because it's off your formula sheet, even if you forget. Which I can write it as the word and. So I want the intersection of M and N. So what's an M and an N? What numbers are an M and N? 3 and 5, which is A. What does the little n mean? No, yeah, amount. Number of elements in, right? So if I ask you what's not in N, that means what's not in N but in the universal set. So N has 1, 3, 5. So not N. So if no. So you'd say not N. If you did not N without the little n, it would go not N equals, and then you'd list 2, 4, 6, 7, 8, 9, which is great. But that wouldn't fit in a numeric response box, correct? So then they'll ask for the little n, then they want the number of elements in which will fit in a numeric response box, which is 1, 2, 3, 4, 5, 6. Which of the following statements is false? So consider the following. And the little, this means the subset. So everything in this is in this. Everything in R is in P. So all the parallelograms are quadrilaterals. That's true. Because a parallelogram just has, it just means that they're like, it's like a rectangle, right? Sides are all the same. Also parallelogram could be a square. Quadrilateral just means it has 4 sides. R, rectangles, are parallelograms. Are all rectangles parallelograms? Yes. These have to be the same length and the same length, right? Or they have to run parallel in order for it to be rectangles.
Parallelogram, like sideways? Like, but it's technically...
A rectangle could be sideways. It's saying that all rectangles are parallelograms. If I said
Diagonal lines?
if I said all parallelograms are rectangles, I'd be in trouble.
The next one?
Parallelograms just mean that.
Like when the sides are like this.
No, parallelogram means that it has 2 sides that are running parallel and 2 sides that are running parallel.
What?
Yes. So this could be a parallelogram, sure.
That's not what I mean though. I'm talking like when you have the 2 sides that are like kind of angled and
It's a rhombus.
that's a
Wrong form of
okay,
vector.
so parallelogram just means that 2 sides.
Parallel. Yeah.
Oh, right.
You went like this. You're going, chunk, 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 right?
They go this way, and then in, and down.
That could be a parallelogram. Like
That's
you
not,
go,
that's only what it was.
oh no, it could be a parallelogram. So these are parallel, parallel. It is a parallelogram, but so is a rectangle is a parallelogram too. Anytime two side lengths, the widths are parallel and the lengths are parallel, it's a parallelogram.
That's so weird. No one ever taught me that ever.
It's because most people would just call it a rectangle, but it's technically parallelogram as well. Squares are also parallelogram.
What?
Well, because these would be parallel and so would these. Right?
I don't think this question. I don't think any of these.
So here it has parallelograms are all rectangles, technically. No, so this is the false one. Okay. Have you guys tried these ones yet? Yes, no? 6 and 7? Okay, we'll do 6 and 7, then we'll stop. You guys can work on some more. So factors of 16 are 1, 2, 4, 8, and 16. Factors of 8 are 1, 2, 4, and 8. Even numbers less than 10 are 2, 4, 6, 8. Okay. Now it wants what's in A or in B. So if it's in A or it's in B, we list it. So 1, 2, 4, 8, and 16. So it's D. This one wants the number of elements in A and B and C. So what numbers are in A and B and C? 2, 4, and 8. So it's 3. Because in A and B and C without the N, it would be 2, 4, and 8. With the N, it means there's 3. Okay, you guys keep working on more. So it says the universal set of natural numbers. Natural numbers start at what number? 1. You naturally start counting at 1. What does the whole number start at? It's the number with a whole plus the natural numbers, right? Integers are negatives and positives and not decimals. Okay, so what is the complement of the multiples of 3? So it'd be 1, 2, 4, 5, 7, 8. It wouldn't include those, so it'd be D. Here it says X, Y, and Z are subsets of U. The shaded area represents what? So X, but not Y and Z, and when we use but not is and, right? Or I would shade X and then I get more. If there's only a little bit of shading, it's 99% of the time it's an and. It's an intersection. So it's X and not Y or Z. Which is A. There is no Y and Z, so you wouldn't pick that one. This one, the shaded region in the diagram represents C, but not A or B. Nope, that's a lie.
Would it be not A or not B? Yeah, it's C, not A or not B and C. Yeah.
Oh my gosh. Forgot let's do a eraser process.
Yes,
Not A.
A.
And if we forget, remember we can do highlighter. So let's go. Not A would technically be all of that, right? Or not B would be all of that. And then if I go or C, it would be all of C. So it would be the whole circle, right? So it can't be or it would be basically everything shaded, right? So we want a small portion, we need an and. Yeah, so it's not A and not B, which would be all that shaded, but then I need and C. So then it would be all the doubles, we're all a triple shaded, which would be here. Yeah. Or you're shading a lot of area. Okay, this one It says, write the number that represents not P in the first box. So not P in the first box. Which one shades not P? 4. Everywhere else is shaded but P. And this one is a debacle. P and not Q. So I need where it's shaded in P but not Q. P but not Q is 2. P but not Q is 2. This one is P or Q. P or Q is what shape? Yeah. P or Q is the snowman, correct? And I want what's not in the snowman, so it's 6. And then this is actually the same, because remember when they're negated, what can I do? I can put the negation outside, P, Q, and then change the and to an or, which actually makes it the exact same as that one. So it's 4, 2, 6, 6.
Wait for the last one when you changed it to P or Q and stuff like that.
Yeah. You do whatever gets you the right answer. So P are the prime factors less than 12. Prime factors less than 12 is 2, 3, 5, 7, and 11. So in P I should have 2, 3, 5, 7, and 11. I'm missing the 2.
It's less than 4 equal.
Or equal to 12. Yeah, but we still, 12 wouldn't be 1. Factors of 12 would be 1, 2, 3, 4, 6, and 12. And then it's the natural numbers 1 to 12. So what do they have in common? They have in common 2, 3, and that's it. And this one should have 4, 6, 12, and 1. And this one should have 2, 3, 5, 7, and 11. The 10 and the 8 and the 9 sit outside because they don't fit anywhere. So write the smaller of the 2 misplaced digits in the first box, and then the next one, so 1, 2. Because 1 and 2 are in the wrong spots. This one here says, remember when it says onlys, we don't subtract, correct? When it doesn't say onlys, we do subtract. So here we need many grade 12, and there's many things to do in Alpha 12, and there's also many grade 12 students. This is such a weird way to start session. In a high school specializing in fine arts, were enrolled in concert band and or music. The number of students enrolled in the course is shown. So we have to start at and always. So concert band, music. Would you have to start at the and? For these ones, I can actually start anywhere, because there's onlys, ands, and neithers. Every single one of them isn't going to get subtracted. So concert band and music, 22. Concert band only, 41. I don't subtract. Music only, 37. I don't subtract. And neither course is 16. I could have put these in any order because of the onlys. You would subtract if it said concert band or music and it didn't have the onlys. So we do 22, 59, 60, 80, 96. Isn't an answer. 116, how bad did I count? 37 and 22, 59, 59, 60, 100, and 16. I don't know what, I think I added 20 instead of 40. Who knows? Bad math. 116. The number of students enrolled in music, so I have to add the 2, so it's 59, 22, and 37. The number of students enrolled in music or concert band is 116 minus 16, because or is the whole snowman. So it's going to be 100. The number of students enrolled in not enrolled in concert band. Not enrolled in concert band. So if I count up concert band, it's 63. So I do 116 minus 63, and I get 53. So this one says the empty set contains no elements. The set A contains one element and has two subsets. The empty set and A. The set AB contains two elements and has four subsets. 0, A, B, and AB. The number of subsets in ABC would be what? This could have empty set, or it could have A, B, C. What else could it have? AB, AC, and then BC, and then ABC, right? So we could have 1, 2, 3, 4, 5, 6, 7, 8. You're literally just timesing the previous amount of subsets by 2. 1 times 2, 2 times 2, 4, 4 times 2 is 8. The number of subsets in this one, oh boy. So we have 1, 2, 3, 4, 5, 6, 7, 8. So with none, we had 1. With one letter, we had 2. With 2 letters, we had 4. With 3 letters, we have 8. Do you see pattern? 1, 2, 4, 8. How many letters are in this one again? I can't remember. 8. So with 4 letters, I'm going to have 16. 5 letters, I'm going to have 32. 6, I'm going to have 64. 7, I'm going to have 128. And 8, I'm going to have 256. You can try and find all those subsets, but you're probably going to miss 1 or 2. Or 50. So you have to find the pattern, right, basically, to get that last one, which we're not really pattern questioning, so I wouldn't really worry if you don't get that one right. But it would matter if you couldn't get this one. Remember, the empty set is a subset of itself, and the empty set is a subset of anything. And you know the subset, anything can be a subset of itself. So A is a subset of A, correct? And B is a subset of B. They're a subset of themselves. So this one here says, all the grade 11 students at a local sports school were surveyed about which fitness activity they would like to take in grade 12. The results are shown. Weight training, cross country, weight training and cross country, and neither. So this one didn't give onlys, correct? So I have to start off with the and. And I have to put a box around. I have weight training, and I have cross country, and is 13, and neither is 28. Now weight training, there's 34, but there's already 13 in the weight training bubble. So how many are just weight training only? 21. And then this one here, there should be 39 in the cross country bubble. There's already 13, so there's 26. So I want the number of in the universal set. So if I go 21 and 26, I get 47, 50, 60, 88. B. The number of students who would not like cross country. So we add up the 21 in weight training only and the 28 outside, which is 49, which is C. The number of students who would like to take weight training or cross country is everything but the 28. So 21, 13, and 26, which is 60. And then 18, if the universal set of negative numbers and S, then not S would be, oh goodness, X is the universal set of negative integers, such a stupid question, and S is greater than negative 2, then it would just be less than negative 2. I guess it could be less than and equal to, because this one doesn't have an equal to sign, hey? So it'd be this one, it would be. Don't suspect something like that to come up on you. Okay, this one has students in a class were told to consider the set of the natural numbers up to and including 25. And they were presented with these certain subsets. Up to and including 25 and natural numbers, the universal set would be this. Q is represented by, what is Q? So we could draw this out. We could go P, we could go Q. P and Q is 8 and 20. P has 2, 3, 8 already is in there, 13, 17, 20 is already in there, and 23. And then or is the snowman, so it's the whole thing. I need 1 here. I already have 2, 3. I need 5, 7. I already have 8, 12. I already have 13, 17. I already have 18, 20, and then 23. So they want what's in Q. So Q would have 1, 5, 7, 8, 12, 18, and I counted 20 twice. 12, 18, and 20. So be D. We're just going to go down to these ones. So here it says, how many roots are there from A to B? How do we do the roots ones? We fundamental counting principle, right? So there's 3 paths here and 3 paths here, which gets me how many? 9. There's 2 paths here and 2 paths here, which gets me? What do I do those 2 numbers? You need to take these paths and these paths to get to the end? Really? All those paths? Every single one of them?
Yep.
No, that's not true. You take these paths or these paths. So what am I going to have to do with them? Add them. So I get 13.
Is that what I thought you did the question wrong if I multiply them?
Yes.
Because it would be D if I multiply them.
Yes. Because if you multiply them, you're saying you need to take every single one of those to get to B. Which I really hope that doesn't happen, because that's chaos. If you get to B, but then you're like, no, I must take more paths. And then you go back, try again. Okay, this one, hockey. What do I do when I get a word? Make sure there's no repeating letters. So if I write out hockey, the word hockey, and I'm just literally rewriting the word, then I don't have to divide by any factorials, right? Because there's no double ups or triple ups. So the number of arrangements of all the letters in the word hockey, and you have to watch because sometimes we arrange 3, 4, sometimes we arrange all. Hockey is 6 letters, so it'll be just 6 factorial because there's no, I start with an H, end with whatever, which is 720. Here we have a committee consists of 11 elected members. From this committee, a president, a treasurer, and a secretary have to be chosen. Permutation or combination? Permutation because order matters because we gave them jobs. So it'd be 11P3. 6 children and 5 adults are to be seated in a row so that none of the children sit beside another one. So we can go, we're arranging them, correct? We're putting them in order. We're standing them, we're aligning them in a row. So C and D are out because those are C's, and that means the order doesn't matter. How many people, which do I have to start with? Children or adults in order to have them not double up? The kids, right? So I'd have to go 6, and I have to put a child here, then a child here, 5, child here, 4, child here, 3, child here, 2, child here, 1. And then I would have to go adult here, 5, adult, 4, adult, 3, adult, 2, adult, 1. How else could I write this instead of going 6, 5, 5, 4, 4, 3, 3, 2, 2, 1, 1? Yeah, 6 factorial for the C's, 5 factorial for the A's, and you're multiplying them all together. So it'd be B. So a car dealership has 5 different models of cars in the showroom. The 5 cars are to be displayed in a straight line. Different models matters. Why does different models matter? Then there's no repeat. They all look different. There's no repeating letters. So like, right? If you had like brown and black, brown cars, and they were all different models, you could tell the difference between all of them. I don't know. I picked brown. It's the most, picked car color out there. Anyways, there are 5 cards displayed in a row. 3 are blue, 1 is black, 1 is green. Now, if they were the same model, I'd have to go 3 factorial on the bottom. Now, it says the number of ways in which all the cards can be displayed in the showroom if no 2 blue cards can be together. If no 2 blue cards can be together next to one another. So we'd have to go blue, 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 right? It'd be like the up. So we go 3, 2, 1, and then 2, 1. Which would be... Now, this one here I want to go over before you pack up. So it says this one and this one. The number of different 6-letter permutations of banana. B-A-N-A-N-A. So banana is 6 factorial, just like that other word was up there, but what do I have to remember to do? Divide by what? 3 factorial and 2 factorial in brackets. Remember, if you don't do it in brackets, guys, it's going to go 6 factorial divided by 3 and then times it by 2, which is not what you want. This one I wanted to talk to you about because people forget about this one. The schedule in a soccer league consists of each team playing every other team twice. There are 6 teams. So remember I told you to always do this as a C? So you do 6 teams, choose how many to play at once. How many teams play at once? 2. In soccer, 2. So we do 6C2, and then all you do is times it by how many times you want them to play each other. So if they play each other 3 times, times it by 3. If they play each other twice, times it by 2. These ones, they play each other twice, so we're going to times it by 2. Right? Don't forget about how to do ones like that. Same thing with shaking hands. Say there were 30 people shaking hands. Well, how would I do that? 30. Choose how many people to shake hands at once? 2. And that's them shaking each other's hands once. Sometimes they shake each other's hands 3 times. I'm like, that's weird. I don't know why they're doing that, but okay. And then I just times it by 3, and I don't even question how weird that is, that they're shaking each other's hands 3 times. But it would be the same thing as if they played each other in a team, right? Same thing.